We have a special episode today that was originally recorded as part of the CUTalks podcast by CUTech, which is the Cambridge University Technology and Enterprise Club. So this episode was hosted by Shreya Singhal and Thomas Bone as part of the CUTalks by CUTech podcast, and it was produced by Carl Homer from Cambridge TV. If you're interested in more of their podcasts, you can head over to the CUTalks podcast on any podcast player that you use.
Welcome to CUTalks, a podcast series by CUTech, the Cambridge University Technology and Enterprise Club. This episode was sponsored by DesignSpark, design tools and resources for engineers to help make their ideas happen. I'm Shreya.
And I'm Thomas, and we are your hosts for CUTalks, a series for aspiring innovators in which we talk about the typical and not the typical journeys of making ideas reality and changing the world.
This week on CUTalks, we're very excited to welcome Patrick Short, co-founder and CEO of Sanogenetics, which aims to connect people with research in personalised medicine. Patrick has a background in bioinformatics research, having completed a PhD in mathematical genomics at the Wellcome Trust Sanger Institute, and previously employment in data science.
We are very much looking forward to speaking to Patrick about the field of personalized genomics, as well as his personal insights as a tech startup founder.
Hi Patrick, thank you very much for coming on the show with us today.
Great to be here.
If you could start off by giving us a bit of an overview of your background.
Sure. So I'm from the U.S. originally. I grew up in North Carolina, which is on the East Coast, if you haven't been there before. I moved over here to Cambridge about 5 years ago to do my PhD. So it was in mathematical genomics and medicine, looking at genetics of rare disorders especially. So I worked on a project that looked into about 10,000 families here in the UK that had rare intellectual disabilities or other developmental disorders. Towards about halfway through my PhD, I started working on a startup company that I'm now working on full time. It's called Sanogenetics. So myself and two co-founders, Will and Charlotte, we started the company in 2017, but we really didn't start working on it full time until about a year ago. Actually, it was September last year that we all went full time. So in a nutshell, the company, we founded it because we felt like everybody's starting to use health data, genetic data especially, but there wasn't a lot of clarity around how data was being used from the perspective of a patient. So we decided to try to build a platform that gave patients full control of their data so they could see how it was being used, opt in and opt out of research. And we hoped by basically having a forcing function for researchers to interact with patients that we'd improve the quality of research. So you can more easily recontact patients for more information, interact with patients and patient groups more closely. Basically, there are a lot of reasons why that makes research better because you actually stay in touch with the person you're trying to help at the end of the day. So that's me in a nutshell.
Great. And is that what Sanogenetics does today, essentially? Yeah,
that's right. So we're kind of a two-sided company in a way. We have a patient-facing platform where anyone can sign up. It's generally most useful or interesting to people who have a genetic condition because the goal of the platform is to connect people with research. And then the other side of the platform is us working with researchers to help match people with clinical trials and more early-stage research, looking at why diseases happen in the first place, or maybe why some people respond to treatments while others don't, and always using kind of genetics as a key ingredient to understand this.
So personalized genetics is probably quite a new thing for some of our listeners, certainly for me. Can you tell us a little bit about what is personalized genetics?
Yeah, definitely. So if we kind of take a historical lens, the first human genome took about 10 years to sequence, about 1990 to 2000, 2001. It was a painstaking international effort, took about $1 billion worth of investment over that period. But since 2001, there have been quite a few technological improvements which have caused the price to drop dramatically. So from $1 billion to today, it's a couple of $100 if you're doing it at large scale. So it's the many orders of magnitude faster than even the drop in computing power, the drop in cost of computing power. So that has meant that, I guess, from the perspective of humanity, we can sequence genomes a lot more cheaply and quickly than we might have otherwise anticipated just 10 or 15 years ago. So this opens up a lot of interesting avenues of research. So when you say personalized genetics, one application, and what I worked on in my PhD, was diagnostics. So for children with severe genetic conditions, we can now do whole genome sequencing to not just look at a couple of genes where the doctor thinks maybe those are the genes involved, but you can look at all 20,000 plus all of the non-coding genome where we still don't really know what's going on there, but to get to a diagnosis faster. There are also applications in understanding why some treatments work better than others. So there are probably several dozen different genes today that have been implicated with safety issues with particular medications, for example. So that's a whole field of pharmacogenomics. And something that we're just getting started on is early detection. So can you predict that someone's going to have a stroke or cardiovascular disease or hereditary cancer based on their genetics and do something earlier? That's something that's not in the healthcare system yet, but hopefully is coming soon.
So what are the advantages of somebody who maybe doesn't have a severe disease or a rare disease, so kind of a normal person walking on the street, knowing about their personalised genomics data? Because there are obviously some advantages and kind of interest in just knowing more about yourself, but also some large disadvantages to knowing that information?
Yeah, definitely. So I think the latest figures are that 26 million people have bought a direct-to-consumer genetic test, and the vast majority of that demand is driven by interest in ancestry and ethnicity. So that's a key thing you can learn, that the science is pretty advanced on. It's still not perfect, and the idea of even the idea of what is your ethnicity or ancestry is kind of an interesting philosophical question, because most of the tests kind of benchmark you against recent history. So how do your ancestors map to where people are today? But that's a big area of interest. The other big area is health. So some people, I think, expect to get a lot more out of it than they do. And scientifically speaking, we're still pretty far from direct consumer tests giving people a lot of actionable information, except in a small number of cases like breast cancer risk. But most of the tests that you can buy for a couple of $100 don't really do a good job of this anyways. But there's a certain element of if the consumer is informed and they really know what they're getting out of the test, and there's a certain element of why not. If the person's truly informed, then you should be able to have access to this data and analyze it. But I think a lot of companies have a lot of work to do in terms of matching people with doctors, with genetic counselors that can actually properly explain, if you learn you have Alzheimer's risk, for example, can you do anything about it? How actionable is this information? And ideally before somebody buys a test, they really understand this.
Mm. And if somebody has kind of ownership of their own genetic data, how does that affect things like insurance?
Yeah, it's a great question. So I'm not a legal expert. In the U.S., there's a Genetic Information Non-Discrimination Act, which applies to health insurance. So they technically can't they can't deny you insurance based on a genetic condition, but it's not the case for life insurance. So a lot of people are concerned that their insurance company may ask and use that information against them. Here in the UK, I think it's a lot, and in probably Europe more generally, it's much better because the NHS isn't, in general, discriminating based on people's genetic data. But it's so the Genetic Information Non-Discrimination Act is something that could be repealed. There's no reason to say it's set in stone. So that's a huge concern of people in the US, actually, is because you do this test once, but your genome doesn't change. So it's not like something else that refreshes every couple of years, and your old Facebook photos aren't relevant anymore, but your DNA is kind of for life. So it's a big question to answer.
Are those aspects something that kind of concerns you at Cynogenetics, or is that one step that you're not actually providing to people? Yeah,
so a key piece of the platform that we've built is that whenever somebody adds a piece of data, if they upload direct consumer data they've already had, or if they get a test from us as part of a research project, they have full control over how it's used. So we have what I think is the kind of best platform in the business that allows people to see exactly where their data is being used and opt in and opt out, as new research opportunities come in. And if people choose to donate their data openly to science, they can. But if they actually want to be asked every time, then they can't. One challenge is always, fatigue. Some people don't want to be asked every time. They just want to, they actually just want to contribute. But I think the important thing is transparency and setting expectations right, that if people understand that they're in control and they can make those decisions, it's much better than finding out later that your data is being sold and you might have ticked a terms and conditions that says this is how it's being used, but you haven't really, there's consent and there's informed consent. You have to really understand what you're getting into.
And I mean, what's the position of your company in relation to some of the big pharma or big healthcare companies?
Yeah, so we work with a lot of biotech and pharmaceutical companies, but we do it in a very kind of transparent and upfront way. So no one, it's impossible to enroll someone in a clinical trial without them understanding exactly what's going on. Mm-hmm. So a key part of how we work is that if somebody joins a research project from a for-profit company, they know and they've opted into it. Whereas a lot of other direct-to-consumer companies have been criticized for being not so upfront, where people think they're buying a test and they do get results from the test, but actually it's a little bit like Facebook. You think you've signed up to share photos and messages with your friends, but actually it's then flipped on to target advertisements to you. So we're trying to avoid that by people who sign on the platform know that they're signing on to join research projects and their data is not going to be kind of shuttled around for different purposes.
Mm-hmm. It sounds like quite a complex industry to navigate from a data privacy as well as kind of enrolling people to get on the platform point of view. So what are some of the biggest challenges that you have faced?
Yeah, it's a very regulated industry, and we try to be as on top of things as we can. There's no room in healthcare to move fast and break things. So we have to think long and hard before we do something. Is there something that we need to think about from a legal or ethical or regulatory perspective? And we do that by only working with researchers that have ethical approval for studies, for example. There's also, when it comes to selling or offering free genetic tests to people as part of research projects, we have to be sure that we're only giving people information that they can, that isn't a medical diagnosis, for example, or if the research project is going to reveal some potentially, medically actionable information, that we set them up with a genetic counselor, for example, that can explain exactly, what the risks are of taking part, and if there is a, piece of information that's revealed that they actually have there is a step 2 of you go speak to a clinical geneticist or a GP or a genetic counselor to learn what to do about this, not just receive a report online that tells you something you weren't expecting to learn.
So it's been great to discuss a bit about the personalised genetics industry. Maybe if we can move on to some of your findings as a founder as you've progressed.
Yeah.
So I remember when we met, you were still doing your PhD as well as having just started the company. And now you said you've gone full-time with the company for about a year or so. So could you talk about that journey and how you transitioned from part-time to full-time, and if you think that's important to founders?
Yeah, definitely. So we started the project as actually as part of one of the Cambridge University Entrepreneurs competitions. So if people who aren't familiar with how this society works in Cambridge, every year they have a series of competitions. You start with 100 words and you win £100 if you do well, and they give out 25 or 30 prizes, and it moves on throughout the year to slightly larger prizes. So myself, Will, and Charlotte had done this competition several times before, and really I approached it. I was always interested in entrepreneurship. I was in a research lab in my university in the US where the PI was very entrepreneurial. He's CEO of a company called Carbon now that does 3D printing. And so I always saw science and entrepreneurship as very naturally combined things. But it's not the case with every PhD supervisor, really. So that's, one thing is my PhD supervisor was very supportive of it, but not everybody's is. So that's an important topic, I think, to if you're interested in this, broach with your supervisor early, because if they say no, science and business are complete opposite ends of the spectrum, then it's going to make life more difficult. But we did well in one of the early competitions. We thought what we were working on was interesting and had some legs. So what's great about doing something that's software related at the beginning is you can make a prototype really easily. So we started with basically like the world's simplest prototype, which allowed people who'd already done a direct consumer genetic test to upload their data to the platform and control how it was shared and choose to opt into research studies or not. And we started with a couple of small research studies with other academic researchers, basically. And over the years, working basically nights and weekends in our PhDs, we kind of moved along from there. And, the nice thing about a prototype is it tells you so much. You can then iterate and change and learn what did you think was the case at the beginning that actually didn't turn out to be. And software is much easier than hardware because you can make changes in a couple hours and see what the difference is.
Did you find it valuable to be doing it part-time because it gave you that safety net, or did you think it held you back from making actual progress?
No, I think it was definitely really useful for us on balance. The fact that we didn't have pressure to start making money immediately. We could test out ideas. We could really understand, like the hardest thing in the beginning is understanding exactly what the problem is you're trying to solve and what the solution is that you propose. Like you really have to have both. If you have a solution and the problem didn't exist, then it's a fun kind of science project. But if there's a problem and your solution is no good, then that doesn't work either. So it gave us the time to actually iterate and change things. I think at some point you have to go full time. It's really, if you really want to be in the driver's seat, you can also stay on as a scientific advisor or something, and lots of people really enjoy that. But for us, we felt like if we were going to really, we couldn't be part-time forever, basically. So finishing my PhD was kind of the point at which we said, okay, I can go do a postdoc somewhere and keep doing research, or give this a try and see how it goes. And we were, at that point, we were all really excited about the idea and having some early traction with researchers and raising funding and that sort of thing. So we decided to just give it a whirl.
Yeah, you've already talked about some of the pivotal moments you have had. But at what point did you three realize this is a really interesting business proposition, and this is something we want to devote our time and effort towards?
So I think it would come in waves, at least for me, that as we were building it, interestingly, there were other companies cropping up that once we started, and it wasn't that they were copying us, they just had the same idea elsewhere in the world. And in some sense, that's kind of, it can be scary to see, you see direct competitors popping up. But I think more importantly, you should think about it as there's validation that you're at least solving a problem that's apparent to other people. So a lot of the other companies we saw popping up were actually explicitly blockchain-based solutions to this problem. So data sharing on a blockchain. And I guess what we sort of stuck to throughout the process is that basically we're going after the same problem, but we don't think that's the right solution for a variety of reasons. So we went with different kind of technology under the hood and a different approach as well. But every couple of months we would see, it would either be somebody else going after the same problem in a different way, or it would be research that we saw happening where we thought actually if our platform existed in the way we imagine it, then you could do this project differently or faster or better in some way. I think a key part of what we're trying to build is there's a link all the way back to the person. So you have a person at the other end who's decided to opt into the research, and that means you can go back to that person to ask follow-up questions or to gather a new sample. So if they're interesting for whatever reason, they have a rare genetic variant, you can actually email them and say, hey, would you be willing to come into the lab for additional testing? And the vast majority of genetics projects aren't set up with that use case in mind. So seeing some of these examples where you get to the very end of the article and they say, but they weren't able to get back to the people, so we don't really know, what the next step is. And you just think, man, if we can actually build this, then, some of these really interesting questions we can start to answer. And those are questions that have, potentially profound impact on health and people's lives. So it was gradual, I would say, no kind of light bulb moment.
You already mentioned that you did some fundraising. What has been your philosophy on funding?
Yeah, so we won one of the Q competitions for £5,000, and that we had to have a business bank account to accept that funding, and that isn't for equity or anything. It's just a grant, basically. So that was our first small amount of funding. But when you're early stage, it's amazing what you can do. It allows you to basically do things that you don't have the skills to do. So for us, it was some pieces with web design, for example, make our website better, and some legal work as well to do things that we couldn't do for legal reasons. We didn't go out and raise venture capital funding until we were really sure that we wanted to work on the problem full time, and that we could see exactly how we would want to spend that money. And basically, there was a direct kind of A to B is if we use this, we can use it in a certain way and solve some of the problems that we just can't solve between the three of us. So I think whenever I talk to other people that are at the kind of stage we were at then, I would say not to think of that as that's not the goal, right? It's an obligation more than anything. As soon as you start taking other people's money and committing to doing something, then it puts you on a track where you have responsibilities. You're no longer in the phase where you're just kind of three people nights and weekends. So it makes sense to actually wait until the time is right and you know exactly how you're going to do it, and you're going to spend the money responsibly, because it's otherwise I think you run the risk of just spending it in the wrong way. If you don't really know the problem you're solving or the direction you're heading, then it can be wasted. But this is only my first time doing this and raising money, so it's hard to say for sure. But I got a lot of advice from we were part of the business school accelerator, so we had great coaches and mentors there that helped out, and also through the CU program, there's a lot of good people around Cambridge that will give you an unbiased view of how you should approach these things.
Have you had any hard lessons that you've had to learn in terms of raising funds?
Our fundraising process was relatively smooth. There's always the ups and downs and challenges. I would say the most important thing is to focus on getting the first investor in the door. I mean, from a purely practical perspective, that for good reason, people don't want to commit until someone who they trust has said, I'm committed to this. And so our first investor was Seed Camp, which is a London-based seed fund, and they have done digital health companies, fintech companies. They do quite a few different things, but they were the first kind of person to say we'll commit. And actually, I think they might have given us a check like 3 days later or something. And then after that, lots of other people will say, okay, somebody has basically staked their, they've put their, staked their name to backing this. So it becomes a lot easier there. So anyone who's out there and thinking and early in the fundraising process, there are a lot of people who will say like, interesting. Yeah, it sounds interesting. I'm happy to be, I'm happy if once you find a lead, I'm happy to invest. And you should just kind of take that with a grain of salt and focus on the people that will, make the first move basically, and then go from there.
You mentioned about that you did find that there were direct competitors in the field. So how important do you think it is for early founders to try and differentiate themselves in terms of what they're trying to offer versus how they go about doing it?
So I think about competition in I guess you should be aware of your competitors, especially if they're direct. But I guess there's two flavors of competitors. There's like a category competitor, so someone who's attacking the same problem or same solution. But if they're really small, then they're not your competitor in the sense that your customer is choosing them over you. So, for us, we kind of have two competitors. One is are our customers going to choose they're often going to choose to do nothing is their primary thing that they'll choose to do. So especially pharma companies are known for having processes that don't change very quickly. So they're first, we're going to lose the majority of our business to them saying it's too risky or too early. So our competition in the sense is them, them keeping the status quo. But it's also important to know if there's somebody out there who's tackling the exact same problem and with a really similar solution, you can maybe learn something from them by understanding how they're thinking about it. But also, you just need to be aware, because as you grow and as they grow, they probably will start to become that other category of competitor. Whereas if you're onto a good thing and it's starting to mature as a market, then they'll eventually become your direct competitor. So it's good to, I think, have an awareness, and everybody asks for it in the pitches as well for funding. So you can't get away with saying, well, our competitor is our customers choosing the status quo. They'll just assume you don't know who your competitor is, basically.
What do you wish you'd known?
Oh, good question. I guess and actually people told me this, so I should have known it, but I probably just didn't listen. But things you often feel like you have to go so quickly, and especially when you're in an exciting market and things are changing quickly, they often don't change as quickly as you think. So this is just thinking back to, as a PhD student, we worked on the problem for 2 years before we really decided to go full time on it, and things changed, but it wasn't as if the market completely got swallowed up by one of our competitors who launched 6 months early. So you definitely don't want to be sitting on your heels and taking your time with things. But equally, timing's a funny thing. You can be too early just as easily as you can be too late. So I guess thinking about, especially in healthcare as an industry that doesn't always move as quickly, being patient can sometimes be just as rewarding as putting things out as quickly as possible. There was one direct competitor, one kind of category competitor called, I think they were called DNA Simple, and I remember seeing them. They launched you get paid $50 to send your saliva in, and they were doing a very sort of we've always, getting paid for your data has always been kind of a part of what we were working on, but it wasn't like the whole offering. We were hoping that it's because for a lot of people that's not the primary motivation. But this was a very American. You say we're going to pay you $50 for your DNA, and I remember seeing them and just thinking they're going on TV and they're on Shark Tank, and I was just thinking oh man, this is it's moving quickly. But then a couple of years later, their website doesn't exist. I don't know what happened to them basically, but it's not as if it's that simple, right? You just start paying people $50 and then you've solved the problem. It's more complex than that. So some things can flash and seem like they're taking off, but then you look back and 2 years later, you're not really sure what's happening with it, right? So that can definitely be the case. You don't get distracted by the competitors. You think look at them critically, figure out what they're doing, but you're not really competing with them. You're competing to try to do the best thing for your customer and for the industry.
I think that's a pretty important thing to try and remember, even if it's difficult to believe at the time. Great. I think that's probably all we've got time for today. So we've just got a fun question to wrap up on. So what are some of the weirdest genetic traits that you've seen in sequencing? Because one of my friends showed me that they did their genetic sequencing, and it was something about they thought that when they ate asparagus, their pee smelt weird or something.
Yeah. Yeah, that's one of the well-known ones that some people can. I think it's a scent receptor. Some people can smell the asparagus in their pee, and some can. Or I guess I need to check on this. It could be that some people's pee smells and others don't, but I'm pretty sure it's a scent receptor. The one that I think is really interesting. This isn't offered on direct-to-consumer tests or anything like that, but it was a study done in a group of people in, I think it's an Indonesian archipelago, and they have for centuries, part of their way of life has been diving deep underwater to go fishing. And so they have genetically adapted to be able to hold their breath for, I think, 8 minutes at a time. Some of the divers could do, and they can go deep as well, 40, 50 meters. And they did this amazing genetic study where they looked at both people who were still diving today and people who weren't diving but working in kind of desk jobs but still had a genetic predisposition. They had enlarged spleens and all sorts of other things. So they were basically their evolution happens relatively slowly. So they had desk jobs, but they were still capable of holding their breath for a long time. If they chose to do it after a bit of training, they could have gone up to it. There are other interesting human population studies around altitude adaptation. So people in Tibet, for example, can have totally different red blood cell physiology, so they can hold oxygen for longer. So there's a lot of amazing natural. I find the human natural evolutionary stories to be really interesting.
Wow. Yeah, very cool.
Yeah.
Thank you very much for coming on the show with us today. We've had a great time.
That was great. Thanks, Patrick.
Thanks. Great to be here.
Thank you very much again to Patrick for joining us on CUTalks. This podcast was produced by Carl Homer from Cambridge TV, and we'd also like to say a big thanks to the team at CUTech, who have all been working very hard behind the scenes.
Thank you very much for listening, and please do go ahead and rate us or leave us a review on iTunes, SoundCloud, Spotify, or wherever you get your podcasts. You can tweet us at CUTech to suggest a guest or theme, or tell us about your experiences with applying technical skills at startups. You'll also find us at cutech.io/CUTalks.